Most people are here, so hopefully the video is good enough. Okay, anyway, so we have that equals 16 times 3 to the I times 5 to the j. Okay, so now, what can we do with that? Subtract, exactly. So what do you want to subtract from what?
15, 3 to the I, 5 to the j.
Put it over there, right? So, right, minus 3 times 3 to the I, minus 5 times 5 to the j, plus 1 equals 3 to the I times 5 to the j. What's wrong with this picture? Hmm? Yeah, pretty clear now. This is impossible because the left side is negative, right side is positive, right? So, contradiction, the left-hand side is less than 0, and the right-hand side is greater than 0. So that's pretty easy now. Yeah, I mean it's a little tricky. I mean I don't know if I would call this quite what I put on a test. See, the thing is with this is you also have to remember for the review session I'm not like worrying about like exactly if it's perfect for a test question or not. The thing with this, I think the tricky step is really from here to here. To realize that you want to take one of these 3's and one of these 5's and separate them off so that you can then subtract and get the contradictions. Maybe not totally obvious. Plus there's other ideas like what Stephen suggested, which is a great idea. It's something that anybody would notice, really, I would hope, is that, yeah, you can cancel a term here with this side, but then you can go down that road quite a ways before you realize, it's algebraically hard to work. So. Anyway, that's okay though. Okay, so far so good? Hanging in there? Oh man. Alright, let's try another problem. Just showing you some examples, that's what we're here to do.
Do you want me to move the camera?
Would you mind? Yeah, I'm sorry, I'm going to try not to use that other board too much more. Be careful with that tripod, everything is so incredibly...
Did I do it?
You're good.
Okay.
Thanks. Okay. Beautiful. Okay. So here's number, what are we on, number 4?
Yeah.
Alright, let's just practice one of these. I know you guys are pretty good at these, but I just want to go through one example of it. Let's compute the Legendre symbol of 182 in mod 421. Just want to crunch through one of these problems. And it might not be a bad time to just remind you of a couple of Legendre values that are worth always knowing, which are the Legendre value of -1 in mod P and the Legendre symbol of 2 in mod P. These two are worth knowing separately because they can't really be simplified any other way when you're doing them in a real problem like all the other ones can. So remember, this number is always just 1 or -1. It's just depending on whether the number is a perfect square in mod P. So, can you guys remind me, when do I get a 1 in the -1 case? P is congruent to 1 mod 4, very good. And the only other case, of course, is P is congruent to 3 mod 4. All of this stuff is for odd primes, right? On the bottom, the number on the bottom has to be an odd prime. Please don't flip over something that's even. I think on the test, I forget what the prime was on the bottom. Again, this isn't even, but there were some people that flipped this over. Luckily, I was grading it late at night, so my screams weren't heard too loudly throughout the building when I saw that. Remember, guys, this whole flipping over thing with the quadratic reciprocity law, only if both numbers are prime. Okay? So, I try my best to choose numbers that are not prime right there so you can see it real clearly. Anyway, so, sorry, just had to get that out. We all have to vent from time to time. How about for this one? Do you guys remember? This one's slightly more intricate, but do you remember the formula for 1 and -1?
P is congruent to plus or -1.
Okay, good. And that's in mod what?
8.
Good. Mod 8. And -1 if P is congruent to
Plus or
-3 in mod 8. Very good. Okay, so we might need to use that as we're working our way through this example. Okay, So what would you want to do right here first, and don't say flip it over, since we just talked about that.
Can we check it to front?
Yeah, so 182 is pretty sure it's not prime. So I'm going to split it up. It's 2 times 91. 91, you know what's true about 91 is the first positive integer that most people think is prime, but is not. So you have to be careful. 91 is 7 times 13. So 91 is not a prime. Okay. Great, so far so good? So you just remember the Legendre symbol is multiplicative. So it respects multiplication, that's what we're using so far. Okay. Well, and of course the 421 is prime. I mean, that has to be prime. If this was not a prime number, then it doesn't make sense to even write this symbol down, and then that's on me, right? You've got to make sure the bottom is a prime. So we can go ahead and simplify this one, just from this equation here. So 421 in mod 8.
-1.
-1 or 1? It
Negative
doesn't
1.
matter, they're both going to be 1 either way. Like, so it's 1, you say? Let me see, what did I...
No, it's -1.
Oh, no, I was asking in mod... Okay, I want to know in mod... I don't want to know whether it's 1 or -1. I want to know mod 8, I was asking what is it, mod 8?
Oh, 5.
It's 5. Okay, good. So then that's this case, so it's minus. Okay, now I got it. Okay, so negative Legendre symbol of 7 times the Legendre symbol of 13. Okay. What do you want me to do with the Legendre symbol of 7 in mod 421? Flip it over, and does that cost me a minus sign?
Yes.
Let's remember when it costs me a minus sign. It costs me a minus sign only when both the top and the bottom are congruent to 3 mod 4.
Never mind.
So in mod 4, 7 is congruent to 3, but 421 is congruent to 1. So because the 421 was congruent to 1 mod 4, we flip it over for free. No sign change. Okay? And I guess that's going to apply to this one too. Okay, so I can flip them both over for free. And then, what do I do next? Reduce these modulo 7 and 13, right? Because obviously in mod 7, which is what this symbol is considered in, you can change 421 to anything that's equivalent to it. So what is 421 equivalent to in mod 7?
1.
Yeah, it's just 1, because 420 is a multiple of 7. So this is just negative of the Legendre symbol of 1 in mod 7. And how about 421 in mod 13?
5.
It's 5? Yeah, I think that's right. Yeah, so we get 5. All right. Let's see this out of order here. Yeah, okay, good. So, of course, 1 is always a perfect square in any mod, so the Legendre symbol of 1 is just 1. What would you want me to do with the Legendre symbol of 5 in mod 13? Flip it back over again. Does it cost me a minus sign?
No.
No. See, it doesn't usually cost you a minus sign, because if either of the 2 primes involved are congruent to 1 mod 4, you don't have to do any change to it. So we flip that over, and now mod 5, 13 is easy to reduce. It's just 3. And we can flip it again if we want to, or we can just think in mod 5 is 3 a perfect square, because we can easily do 1 squared, 2 squared, 3 squared, and 4 squared. Okay? And you know that 3 doesn't show up. But the only perfect squares in mod 5, you take these numbers, these are the squares in mod 5, and you reduce them mod 5, you're only going to get 1 and negative 1. So, or 1 and 4. So this one doesn't come up. So it's going to be negative 1. That Legendre symbol is negative 1. Now I have a double negative, so it's positive. You do have a 50-50 chance of getting these problems right. Okay. Those of you who like multiple choice. And it's not even like tricky. It's not like true false where it's tricky. This is like, you have a 50-50 shot and it's just crunch the numbers, so. Anyway, just thought we should review that, make sure that everybody's on the same page. Okay, perfect. What else do we wanna do here? Go on to number 5. Okay, I'm gonna give you some congruences to solve again. We're gonna go back, kind of mixing it back and forth, early stuff, late stuff. So I just wanna try and get through some of these things. So find all solutions, if any, to the following congruences. So here's part A. X is congruent to 5 mod 8, and X is congruent to 11 mod 18. So there's going to be 3 different parts to this. Three different parts to this problem. And I said find all solutions, if any. There may not be any. So think about it.
Bless you.
Okay, so what do you think about this?
You can't use
Our
this.
mods are not relatively.
Yeah, the first thing is always you look at the mods and you say they're not relatively prime, so I can't use the CRT. Now, if somehow you could divide, let's say you could take the second one somehow and divide it through, suppose it was, something like this or whatever. And you could divide the second one through by 2, then you'd have a mod 9 and a mod 8 and you'd be fine. So it might be possible that the mods might not be relatively prime to begin with, but you might be able to do something to make them relatively prime. But in this case, we already have it kind of in the CRT friendly form, right? X congruent to one thing, X congruent to another thing, and the mods aren't relatively prime. Okay. Beautiful. Question?
No,
Or, you have an idea? Go ahead.
you check if the GCD of the mods divide the difference of the two numbers?
That's right. Okay, so we didn't spend a huge amount of time on this, but the basic idea is you take the GCD of the mods, which is what, by the way? 2. And the question is, does it divide? So I want to figure out, does this thing even have a solution first? Because let's not spend a lot of time looking for a solution if there isn't one. So the criteria for testing for a solution here is that the GCD has to divide the difference of these two numbers, which usually we call these A and B. So 5 minus 11, and the answer is yes. Okay. So because of that, there does exist a solution. And in fact, there exists, just to remind you again, there exists a solution X, which is unique modulo. Do you guys remember what the mod is that provides the uniqueness of this solution? Yes, it's the least common multiple of these two mods. Very funny, isn't it? What is the least common multiple of 8 and 18?
GCD, total product divided by GCD.
72.
Yeah, I mean, the reason I was asking the question is because I just wanted to remind you about a little fact that's kind of good to know. The greatest common divisor of two numbers multiplied by the least common multiple of two numbers is equal to the product of the two numbers. Actually, you should be able to prove that. And basically, if you write out prime factorizations for A and B, right, with p's to the power, p1 to the k1, p2 to the k, blah, 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 right, whenever you take the GCD, you're looking at the powers of the primes here, and you're taking the minimum of the two exponents. So if A has a 2 cubed in it, and B has a 2 to the 5th in it, something like that, so then the total number of 2's is 8. Well, on the other side of the equation, for the GCD, you take 2 to the minimum, right, the smallest common factors of 2, which would be 2 cubed. But the LCM grabs the maximum of the 2. So you get the same number of powers of 2 at the end of the day on both sides. These are supposed to be equal and so on. So So anyway, this is how I like to calculate LCMs. I just multiply my two numbers together and divide by the GCD. The GCD is 2. So I just need to multiply these together, divide by 2, and I'm going to get 72. Okay, so this is unique modulo 8 times 18 over 2, which is 72. And we get a unique answer mod 72. I think she's working the camera.
What?
Hey, can you see this stuff over here?
Well, yeah.
Okay, I'm just going to use this little tiny piece here. Thank you. Okay. Yeah, I mean, I used to put the camera way in the back, but then you can't see it, the board that well, so I didn't want to go that far back. Okay. Okay, so now we have to actually come up with the solution. This unique solution. Now that we know that there is one and we know it's unique mod 72, we have to come up with what the solution is. So the way to do that, if you remember, is you have to write the GCD as a linear combination. So the D has to be written as a linear combination of 8 and 18. So let me remind you about that. Basically, 18, you do the Euclidean algorithm thing with 8 and 18. So 18 is 2 times 8 plus 2. And you're done. Yeah, pretty much. So there you go. 8. So it's 18 minus 2 times 8. All right. Beautiful. And let's see. So I'm thinking of. Let me just get the general notation here. This is in the notation that we used in the notes. The n was 8 and the m was 18. And what we want to do here is write the n first. So this is 8 times negative 2 plus 18 times 1. I want to write everything in the same order that it's supposed to appear in. So this is n and this is m. Okay? And then we gave names to these variables here, which are r and s. And then we simply write a minus b, which is 5 minus 11. We simply write a minus b, 5 minus 11, as a multiple of the GCD. And in this case, that multiple would be negative 3 times the GCD, which is 2. And this number, the negative 3, is what we call t. Okay. So just to recap, you just write the GCD of the mods as a linear combination of the original mods in the usual integer linear combination way. You need these r's and s's for the formula that I'm going to give you in a second to remind you the formula for x. So we have to come up with these two numbers, which are r and s, and then the a minus b, which are these numbers, are expressible as a multiple of the GCD, and you just need to call t that multiple, which is negative 3. So then the solution is x equals a minus nRT. Or, this is older material, so you may not quite remember this formula, so that's why I'm writing it down again. Or you can write it as b plus mst. Okay, either one of those is going to work. Let's try it out in this case. So in this case, a was 5.